All right, let's look at the homework 3.10, problem number 7. All right, so it says this: the edge of a cube was found to be 15 centimeters with a possible error in measurement of 0.1 centimeters. Use differentials to estimate the maximum possible error, relative error, and the percentage error in computing the volume of the cube and the surface area of the cube. All right, so let's do that. All right, so the volume of the cube, V, is going to be equal to, all right, X is going to be the size and the cubed, right? So if you want to estimate in delta V, which is the error in finding the volume, we can estimate it using the differential dV. Right, which is going to be simply take the derivative, so it's 3x squared times dx. All right, so let's plug it in. So we have 3 times, all right, x is 15, and we have to square that, and then multiply by dx, which is 0.1. All right. All right, what would that be? 15 times 15, is that 225? Let's just do it. 25 and 5 times 1, 75. So 1, 5, yeah, it's 225. All right, so this is going to be, let's see, 225 times 3 is going to be 675, 675, and then multiply by 0.1, so 67.5. Right, so that will be the 67.5 will be the maximum possible error. Right, so relative error is going to be delta V over V, right, which can be approximated by dV over V, right? So this is going to be, we know that it's a 3x squared dx, and the volume is x cubed. All right, so we can cancel x squared here, so there's going to be still x on the bottom. So this is going to be 3 on top, and dx is 0.1. and divided through by x, which is 15. All right, so this is going to be, so 3 and 15 cancel out, 5. All right, 1 over 5 is 0.2, and times 0.1 is 0.02. All right, so this is going to be 0.02, and which is 2%. All right, and let's type it in. All right, so we got 67.5, and then we have 0.02 there, and then that's 2%. All right, so let's submit for testing. All right, and all right, it came back, and looks like we got the part A correctly. All right, so let's do part B. All right, so part B is a surface area, so I'm going to call it, say, A. So area is going to be, so each face has an area of x squared. Then you have 6 of them, right? So we want to find error in finding the area is going to be, can be approximated by dA, which is, derivative of that is 12x times dx, which is going to be, right, 12 times 15 times dx is 0.1, right? So 15 times 12 is going to be 30, and the 15, so it's going to be 180, right? So this is going to be 18, right? So we have 18. And the relative error is going to be delta A over A, right? So this is 12x dx divided by 6x squared. So we can cancel 6 and 12, so it's going to be 2, and the x cancel out here. So what you get is going to be 2 times 0.1 and divided by, right, x, so 15, right? So this is going to be, let's see, what's the best way to do it? So I'm going to multiply top and bottom by, say, 5, and so it's a 0, so it's going to be 1 over, multiply by 5, so it's going to be 75, right? So we got the relative error to be 1 over 75, right? Then if you want to find the percentage error, you just have to multiply by 100. So if you multiply 1 over 75 by 100, you're going to get, let's see, 100 over 75. So it's going to be 4 over 3, right? So this is going to be 4/3, right? So let's type it in. All right, so we got 18 here, and then here is 1 over 75, and a percentage-wise, it's going to be 4/3. Right? So let's submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.